Trig identities are formulas that are true for any angle. Let's start off with an example by seeing if we can find a formula that's equal to the sine of 2 times an angle, which we'll call A. If we set A equal to these inputs, what are the outputs you get for the sine of 2A? Remember that you can use the calculator down here to help you out. And if you'd like to review the sine function instead, then click over here. Great, so these are the outputs you got for the sine of 2A. Next, let's look at another function of A, the sine of A times the cosine of A. Again, for these same angles, what are the values of sine A times cosine A? Nicely done. Here are the outputs you found. Let's take a closer look at these outputs. It looks like for any angle A you pick, there's a relationship between the sine of 2A and sine A times cosine A. What's the missing coefficient in this equation? In other words, for each row of this table, what number can you multiply sine A cosine A by to get the sine of 2A? Exactly right. And this is an example of a trig identity, which is a formula that's true for any angle. For any angle A, the sine of 2A always equals 2 times the sine of A times the cosine of A. There are a whole bunch of trig identities that you can explore and prove, just like this one, and they come in really handy later on in calculus. If you're curious, check out the different trig identities next. Let's see if we can find some trig identities for the sine, cosine, and tangent of the sum of two angles, which we'll call A and B. So we want to write the sine, cosine, and tangent of A plus B in terms of these expressions over here. Let's get started. Suppose these are our two angles, A and B. Let's go out a distance 1 along this top line and draw another line that's perpendicular to this line here. And let's do that again, drawing a line that's perpendicular to the line at the bottom. First off, what's the length of this side up here? If you're not sure how to get started on this question, definitely click down here to review. Right, this side's length is equal to the sine of B. Now what's the length of this side down here? Exactly, the length of this side is the cosine of B. Next, what's the length of this side over here? If you're not sure, just click up here. Right, so the length of this side is sine A cosine B. And what's the length of this side down here? Right, this side has length cosine A cosine B. Just a few more geometry questions and then we'll have our identities. Let's draw another right triangle up here. What's the measure of this angle in terms of A or B? Okay, let's figure it out. Let's first look at this angle down here. What's the measure of this angle in terms of A and B? Precisely, this angle has measure 90 degrees minus A. And remember, this is a right angle over here. So, what's the measure of this angle up here? So this angle also equals A. Try using this fact to figure out the length of this side up here. And what's the length of this side all the way up here? Nicely done. So now we have the lengths of all these sides. It's time to find some identities. Let's draw one more right triangle here. What's the length of this side over here? Right, this length is the sine of A plus B. Now which sides here add up to the same length as the sine of A plus B? Exactly, the sine of A plus B is equal to the sum of the lengths of these two sides. And there you have it. The sine of A plus B equals the sine of A times the cosine of B plus the sine of B times the cosine of A. And that's our first identity. This formula is true for any angles A and B, even for angles that are larger than 90 degrees or negative. Let's go back to our other right triangle. What's the length of this side on the bottom? Okay, so this length here is equal to the cosine of A plus B. It looks like it might be related to this length up here and this length down here. So let's find the next identity. What's the cosine of A plus B in terms of the sines and cosines of A and B? And that's our second identity. For any angles A and B, the cosine of A plus B equals the cosine of A times the cosine of B minus the sine of A times the sine of B. Let's use these two identities to find a third one, an identity for the tangent of A plus B. What's the tangent of A plus B in terms of the tangent of A and the tangent of B? Very nicely done. So for any angles A and B, the tangent of A plus B equals the tangent of A plus the tangent of B over 1 minus tan A tan B. So congrats! You found the trig identities for the sine, cosine, and tangent of the sum of two angles. Let's see if we can find some trig identities for the sine, cosine, and tangent of negative angles. So we want to write the sine, cosine, and tangent of negative A in terms of the sine, cosine, and tangent of positive A. First, let's look at the unit circle, which is the circle centered at the origin, which is the point 0, 0, and with a radius of 1. Say we're looking at an angle theta, and suppose it hits the unit circle up here at the point x, y. What's the cosine of theta in terms of x or y? Right, cosine theta equals the x-coordinate of this point on the unit circle. Next, what's sine theta in terms of x or y? Exactly, the sine of theta equals the y-coordinate of this point. So the coordinates of this point on the unit circle are x, y, which is the same thing as cosine theta, sine of theta. So this point and this line here on the unit circle represent the angle theta from the positive x-axis. Which of these other lines represents an angle of negative theta? And if you want to quickly brush up on negative angles, then click here. Right, this angle down here represents negative theta. The angle is the same size, or magnitude, but clockwise from the positive x-axis. Just as the coordinates of this point up here are the cosine and sine of the angle theta, the coordinates of this point down here are the cosine and sine of this angle, which is negative theta. First, let's find an equivalent expression for the cosine of negative theta. The cosine of negative theta is the x-coordinate of this point down here, so it's the length of this line here. So how does the cosine of negative theta relate to the sine or cosine of positive theta? Which of these expressions over here is equal to the cosine of negative theta? Right, the point at positive theta and the point at negative theta both have the same x-coordinate, so cosine theta equals cosine of negative theta. And that's our first trig identity for negative angles. Next, what's the sine of negative theta equal to? Remember, sine of negative theta is the y-coordinate of this point down here. Nicely done. The point up here and the point down here have opposite y-coordinates, so the sine of negative theta is the negative of the sine of positive theta. And that's our second identity for negative angles. Try using these two identities to find an equivalent expression for the tangent of negative theta. So the tangent of negative theta equals the negative tangent of positive theta. So here are the three trig identities for negative angles. And remember, they're true for any angle you pick.